Hey, what's going on, guys? Welcome to jumper1.com. I'm Phil Levchenko, and today I made a small tutorial on computer power supplies. How can you use them, how to connect them in series, in parallel, what do you need all these wires for, and finally how to build your own lab bench power supply out of computer power supply.
What is an ATX power supply? ATX power supply is a pretty powerful switch mode power supply with 4 different output voltage levels, which is 3.3, 5, 12 and low power negative 12 volt rails. And in older versions you will have an additional low power negative 5 volts rail. There is one major difference between older versions of ATX power supplies and the newer versions: amount of power it can provide on each rail. In older power supplies, most of the power was on 3.3 and 5 volt rails, and the rest of the power is on 12 volts rail. And in newer versions, because of appearance of highly efficient DC-DC converters, which supplies high current low voltage where it needed, most of the power moved to 12 volts rail. So if you're into some high power stuff and you need high current on 12 volts rail, you would want to look for newer power supplies. New power supplies have 2 or even more 12 volt rails. They called 12V1, 12V2 and so on. So what does it mean? It means that there is only one transformer output, like in older power supplies, but there is a separate overcurrent protection on each of these rails. And if one of these rails would be shorted out or overloaded, the power supply will just shut down. And yes, you can connect these rails together and therefore you will get more current on the output. Connecting power supplies in series. You can connect them in series, but because in computer power supplies mains earth directly connected to the ground, you need to disconnect mains earth from one of the power supplies or you will short out the other one. And be careful, chances of getting an electric shock will substantially increase. Plus you can get more ripple and noise on the output. Connecting power supplies in parallel. You can't connect these power supplies in parallel, because one of the power supplies will take most of the load and the other one will pick up the rest. Wiring. Standard ATX power supply comes with different wire colors. Black color is a ground, orange is 3.3 volts, red plus 5 volts, yellow plus 12, blue it's a negative 12 volts, green it's a power on, purple plus 5 volts standby, gray it's a power good, and brown it's 3.3 volts sense. Also in old power supplies you will have a white wire, which is negative 5 volts. And be aware of Dell power supplies, they might have a different wire's color coding. To turn on power supply you need to connect green power on wire with black ground. In most cases, power on is pulled up to plus 5 volts standby with a small resistor, usually 20 to 50 kilo ohms. So you can use any logic level switch or microcontroller output to switch on and off ATX power supply. Plus 5 volts standby provides about 1 or 2 amps 5 volts when power supply is not on, but while mains is connected. Power good is low when other outputs have not yet reached or about to leave a correct voltages. And usually it takes 1 or 2 tenths of a second to reach normal voltage levels after power on. And finally, 3.3 volts sense is needed to monitor voltage drop across 3.3 volt wires. Because wires represent a small resistance and with small voltages and big currents, voltage drop could be very significant. So you need to connect sense wire to the end of 3.3 volt wires to keep it at that level all the time despite a different load current. And the last thing, computer power supply is a switch mode power supply, and any switch mode power supply needs at least some load on the output, or it won't start or will be very unstable. So in order to convert computer power supply into a lab bench power supply, you need to put some dummy load on the output. For old power supplies before Pentium 4 times, you need to put a dummy load resistor between ground and plus 5 volts, and for newer power supplies, between ground and plus 12 volts. In most cases, about 5 watts dummy load would be more than enough. So here I've got my old power supply. Back in the days I was using it for testing power consumptions of different motherboards. And as you can see, most of its power is on plus 5 volts rail. For this build you're gonna need a binding posts, main switch and low current switch, dummy load power resistors, heat shrink tubing, two pieces of prototyping board, two LEDs and current limiting resistors, and some tools. And of course that's not all of them. Take the cover off and be careful, those two big caps could be charged to mains voltage. Cut the wires and separate them by color. Now it's time to think where to put all those binding posts, switches and LEDs. When drilling holes, I recommend you to use a small drill bit first and then go to big one, or even use a few sizes in between. Put the binding posts, switches and LEDs into place and make sure that they don't touch anything inside. Connect all those wires to binding posts. Make sure that wires will not touch anything inside under any conditions. Connect mains to the switch and isolate overall mains wires and the switch. Start connecting load switch and LEDs. I place current limiting resistors for LEDs in heat shrink tubes. Then connect switch between ground and power on, the green wire. Connect one LED between ground and one of the positive outputs of power supply. Connect the second LED between ground and plus 5 volts standby. And don't forget to use current limiting resistors in series with LEDs, or they will release the magic smoke. Insert resistors into prototyping board and bend leads on the back, so that resistors will not vibrate off. Then solder them to the board. For this build I used two 5 watts 11 ohms resistors connected in parallel to plus 5 volts and the ground. In case of newer power supplies, you need to connect them to plus 12 volts. Use the other board as an isolator between resistors and power supply case, and leave some space around each resistor to allow free airflow. Hot glued LEDs to the case. Put back the top cover, connect mains cable, and let's try to switch it on. And looks like it works. It looks like mains LED has some turn-off delay because of a slowly discharging caps. Finally, put labels on the front. And here's the final result.
So I hope you liked this video, and you can find some additional information on jumper1.com, and don't forget to subscribe. See you guys later. Bye.